Right. So we have seen the NAND and NOR realizations in the last class. So in specific, we have seen the NAND relation. So we'll see one or two problems related to NAND relation only. Okay. So afterwards, we'll continue with the NOR relation. Okay. So NAND relation, we'll see of two more problems. So we'll be giving the expression. The problem is draw the multi-level and multi-level NAND circuits for the following expression. Right. Yeah. So F is equal to AB bar plus CD bar into E plus BC bar into A plus B. Okay. First, draw the circuit using AND OR gates. Okay. So AND OR gates to draw cheddamu. So tarvata will shift it to NAND gate. We'll convert them into the NAND gate. So we know the three rules, right? So convert them into the NAND gate. So we'll check them. Okay. So first of all, so we'll draw the circuit. So first AB bar plus CD bar. So we'll use an AND gate here. One AND gate, and this is the another AND gate. Okay, this is A B bar. This is C D bar. So it is given to OR gate. Okay, and into E. So we'll be having a E here. So that E is going to output of this. It is going to an AND gate. This is AB bar plus CD bar into E. So this is the value here. The next one is BC bar, which is given to another AND gate. So B C bar is given to an AND gate, and A plus B is given to an OR gate. So AB is given to an OR gate. So both of them, the expression is, so these two are to be added. So the expression, so what we got in the earlier one, so this is given to an B plus BC bar, and these two should be multiplied here, and so what are the expressions we get here? So given to an OR gate, because OR gate is addition, used for addition here. So till now this is clear?
Yes, sir.
Yeah. So next what we have to do? So we have to convert this AND gates to AND invert and OR gates to invert OR. So those are nothing but the NAND gates. So AND invert will give you the function of NAND gate here. Invert OR will give the function of the NAND gate. Okay. So first give the bubbles here. So OR gate is invert OR only. Okay. So this is the second step. So you draw it separately. Okay. So we separate the draw change. So don't overlap like this. This is the thing here. Okay. Now what we have to do here? So we have to check each bubbles in each row. So bubbles in each row are checked now. Okay. So each row of bubbles check చేయాలి. So we'll see whether even number of bubbles are there. So there is a compensation of the bubbles, or else what we'll do? So we'll change the inputs, we'll complement the inputs, or we'll insert an inverter. Okay, we'll insert an inverter. So we'll see here. Right, this is the first line. First bubble is compensated with second. So even number oste parledu. So there is no need of extra one. Okay, so hence this line is okay. Okay, and second line. So 1, 2, 3, and 4. So this is also okay. And check the value of E here. So E, we have one bubble, and it is compensated by second bubble here. So no problem with E also. Okay, and next we have this one. Okay, so we have this one. This is 1, and this is 2, and this is 3. So it is not compensated. And here also this is 1, and this is change the color. Yeah, this is one bubble. This is the second bubble, and there is the third bubble. So we have 3 inverters, so it's not compensated. The same way, this one is here. It is 1. Here it is 2, and here it is 3. Okay, so there is no problem with this part. So it's fine. Okay, so the only problem lies with the downside. Okay, the only problem lies with the downside here. So what is that we had here? So BC bar. Okay, so BC bar. So we have 2 options here. We can change the inputs. So AMG manam. So we can write it as so B bar C. Okay, and here also we can write it as A bar B bar. And then, so complement the inputs. So what we'll do here is complement the inputs, or else we have one more option. So what we can do, we can if it is like B bar C only. Okay, if I have B C bar only. So if I don't want to change this, so can use a one input NAND gate here. So one input NAND gate is given. So which functions as an inverter. So then we can have 1, 2, 3, and 4. So 4 bubbles. Okay. So any option is okay. So we should know that. So the bubbles are not compensated. So we can insert an inverter there, or we can complement the input literals there. So those are the 2 options available. So you can do whatever you want. Clear?
Yes, sir.
Yeah. So as of now, so I'll insert an inverter like a one input NAND gate. So no problem. But here I'll change the complement the inputs. So 2 options చెప్తున్నా మీకు. So 2 options are possible here. Okay. So if I want to draw only using NAND gates, so this will be the thing here. So we started with the first section is fine. So this will be the final diagram. that is given to invert or what is, so I can write another NAND gate here. Okay, so this E is given to another right. This is AB bar plus CD bar into E. This is the expression here. And next, it is like BC bar. So I'll be using an inverter. Inverter is one input NAND gate that is given to inverter. So inverter is one input NAND gate. So draw the symbol correctly. Okay, and I'll complement the other inputs. So two possibilities are there. So we are showing the two possibilities here. So one is complementing the inputs here. The other one is inserting an inverter. Okay, so the main thing is like, so all the bubbles should be compensated. So if a line, check in a line, all the bubbles should be compensated here. So this is bubble here, and this is F. Clear?
Yes, sir.
Okay, so take one more problem.
No, sir.
Huh? What no? Which no? Please let me know if there is any doubt.
Okay, proceed.
Yeah, tell me. Doubt unte cheppandi parలేదు. So that doubt should be clear right now. So that
No doubt, sir.
yeah. So anyone you can ask, right? So you can take another problem. So realize the following Boolean function. Let's take the problem here. There is the following Boolean function using only NAND gates. So F is equal to BC bar plus A bar D into AB bar plus okay. So we have two sums here, and that should be multiplied. So product of sums. Okay. So draw the diagram first, and or gate to draw the ending. Right. So gates symbols magic draw చేయండి. This is B C bar. So A bar D. So both are added. Give it to OR gate. Next AB bar and other one is CD bar. So these two are the products. We have to use another AND gate. So these two are given to an OR gate, another OR gate. The two OR gates are given to an AND gate. So this is normal AND OR implementation. So now we have to go for using NAND gates. So if I want to use only NAND gate, so what I have to do here is, so NAND gate should be converted, AND gate should be converted into NAND gates by using AND invert, that is bubble for every AND gate. Okay, and OR gate should be converted into NAND gates by using OR invert OR. So this is bubble. Okay. Now what I have to check here is, excuse me. Yeah, what I have to check here is bubbles in each and every line. You can see here this is 1, this is 2, and this is 3. So 3 bubbles, not compensated. And this is 1, this is 2, and this is 3, not compensated. And you can see here this is 1, this is 2, and this is 3, not compensated. So 1, 2, and 3. And here also 1, 2, and 3, not compensated. So for every gate, so we are bubble is not compensated. So what, instead of changing the complementing the inputs, what I can do, I can insert an inverter here. I'll insert a inverter, that is one input NAND gate here. So hence we can see the compensation. So 3 and this is 4. Okay, this is 3 and this is 4. So this is F. Clear?
Yes, sir.
Right. So draw the diagram. So replace this inverter with NAND gates. So NAND gates to draw the ikkada. So if I draw a NAND gate, so then that will be the final structure. So why still people joining? Yeah. So this will be the final implementation of this using NAND gates. Clear?
Yes, sir.
Yeah. And we'll say NOR gates. NOR gates will follow the same procedure. So we'll see the steps here. So the general procedure. Procedure for converting a multi-level AND OR diagram into all NOR diagram is as follows. The same procedure, but కొంచెం చిన్న changes ఉంటాయి దాంట్లో. So convert all the OR gates to NOR gates. Generally, NOR gate is inversion of OR. Okay, so NOR gates. So with OR invert graphic symbol. Okay, the symbols will be like this. This is the OR gate. And you insert a bubble for OR gate here. So that will become NOR gate here. Okay, that is the first step. And second step, so convert all AND gates to NOR gates with invert OR graphic symbol. Okay, and the symbol is this is the inversions used here in front of AND gates. Right, this is the thing here. Right, and third point, the compensations, like compensation of bubbles. So check all the bubbles in the diagram. For every bubble not compensated, so by another small circle along the line. Insert an inverter. So that is inverter, that is a one input. Wait a minute. One input NOR gate. Okay, so one input NOR gate or complement. So this is as earlier, or complement the input literal. Okay, so this is as usual. So why we have to do this? So the properties of, we'll see the truth table of NOR gate here. Okay, so NOR gate truth table. So 0 0 0 1 1 0 1 1. So the output will be, so opposite of OR, so 0 0 is a 1 and remaining OR zeros here. Okay, and 1 1 is also 0. So this is a truth table of NOR gate here. Okay, and if I want to implement an inverter using OR, sorry, NOR. We can check the truth table there. So when the inputs are 0, 0, the output is 1. When the inputs are 1, 1, the output is 0. So hence what we can do here is, so when both are the similar inputs, like a single input is 0, so you can get a 1 output here. So if input is 1, I can get a 0 output. So it can function as an inverter for a 1 input NOR gate. So 1 input NOR gate ni inverter ga function చేస్తుంది. ఎప్పుడు function చేస్తుంది అంటే, so when it is given 1 input. Okay, the symbol will be like this. So 1 input NOR gate acts as an inverter. Here, and coming to the next truth table. So if I want to convert this, I mean OR gate, if I give an inversion, definitely it is an OR gate. And coming to AND gate, so AND gate truth table will be like this. If it is like XY, AND gate truth table is like this: 0, 0, 0, 1, so 1, 0, 1, 1. Output is like F anukundamu, so 0, 0, 0, 1. Okay, so this is a truth table of AND gate here. So if invert AND gate will give the truth table of NOR gate antunaru. Okay, so invert ante I need X bar Y bar. So I need the values of X bar Y bar. So X bar Y bar is 1, 1, 1, 0, 0, 1, and 0, 0. Okay, so now the function is F. So check the truth table of AND gate here. So X bar Y bar, F is 1, 1 here, I'll get a 1. For remaining things I'll get a 0, and this will be the truth table of NOR gate here. This will be the truth table of the NOR gate. So invert and, so that is inversion of the inputs, and will give you the NOR gate here. Okay, so wherever I have AND gates here, so those should be replaced with invert AND, so that it is a NOR gate. Okay, so that is, I mean, wherever I have find OR gates here, so replace them with the OR invert, and wherever I find AND gates, replace them with the invert AND. So general symbol of NOR gate is this one. The symbol of NOR gate is, this is the symbol of the NOR gate, right? So do the same problem. So meeku oka problem ichcham kada, so previous one. So implement that with help of NOR gates. Right, the function is F is equal to F is equal to the same function, the first problem we discussed, ED bar into E, that's BC bar into A plus B. So first implement with help of AND OR gates. Okay, so make it fast. This is A, B bar, C, D bar, and this is E. So all of them are given to this is given to, sorry. So this 2 is given to an OR gate, your summation. Okay, and this 2 is given to an AND gate because it is a product. Okay, and BC bar is given to an AND gate and A plus B. So AB is given to an OR gate. So both of them are multiplied here, so which is given to AND gate, and so these two are multiplied here, so this is given to an AND gate. So there is normal AND OR implementation. Sorry, both addition here. So I have to use a gate here. Okay, so what is that we have to do? So replace all the AND gates with invert. Replace all the AND gates with invert AND. Okay, so AND gates invert AND to replace చేయండి, OR gates ni OR invert to replace చేయండి. So here is a bubble. Okay, and check the bubbles in the each line. This is 1, this is 2, this is 3, and this is 4. Right? And here it is 1, 2, 3, 4. This is fine. And here it is 1, and this is 2, and this is 3. And here also it is 1. Sorry. Here this is 1, and this is 2, and this is 3, and this is 4. This is also fine. This is also fine. Okay, the problem lies with here. So this is also fine here. So here we have a bubble here. 1, 4. A mistake is am I? No mistakes. One and 2. Fine. Okay. So this is 1 and this is 2. It's okay. And here the problem lies with this one. So 1, 2, and 3. 1, 2, and 3. So this is also 1, 2, and 3. Okay. So there are two possibilities here. So మీకు ఏం చేయాలి, కంపెన్సేట్ చేయాలి. సో ఇంతకుముందు ఏం చేసాము, దీని ఇన్పుట్ చేంజ్ చేసి చేసాము NAND gates తో. సో మీరు ఇప్పుడు ఇంకొక చేంజ్ ఏం చేయొచ్చు అంటే, so this is also fine. So what we can do here is I can change this one. So B bar C or A bar B bar. So this is one possibility. Okay, and the second possibility is to use a one input NOR gate here. So there is second possibility. Okay, the third possibility is if I check this, is if I insert an inverter, that is one input NOR gate here. So this will not change. So this will not change. This part will not change, but this will change. So the ఎలా change అవుతుంది అంటే, let's reverse the inputs here. అంతే కదా. Okay. So if I want to, if I insert an inverter here, so all these things are compensated, but ఇక్కడ ఇవన్నీ చేంజ్ చేసుకోవాలి. ఇక్కడ ఇన్వర్టర్ ఇన్సర్ట్ చేస్తే, సో ఆల్రెడీ కంపెన్సేటెడ్ అన్నమాట కాబట్టి ఇవి చేంజ్ చేసుకోవాలి. సో లేదు ఇది చేంజ్ చేస్తే ఇక్కడ చేంజ్ చేసుకుంటే సరిపోతుంది. సో ఇట్స్ యువర్ విష్, బట్ మేక్ షూర్ దట్ ఈచ్ అండ్ ఎవ్రీ బబుల్ ఈస్ కంపెన్సేటెడ్. ఓకే, సో ఆఫ్టర్ దిస్ రీప్లేస్ దిస్ వన్ విత్ ద సింబల్స్. లైక్ ఈ సింబల్స్ అని ఎలా రీప్లేస్ చేస్తారంటే, సో AB bar, like if it is like AB bar, so replace with a, okay, so replace this AND gates with the symbols, invert AND gates with the symbols, okay, and NOR gates with the symbols. So final ga anni NOR gates e undali. Clear?
Sir.
Yeah. So any other thing get out on that? So just same methods, but ఏంటంటే ఇక్కడ NOR gates బదులు AND gates బదులు, సో NAND gates బదులు ఇక్కడ NOR gates యూజ్ చేస్తాం. సో రివర్సల్ ఆఫ్ దట్. Okay, the compensation is very important that you have to take care, and the symbols ఏవి రీప్లేస్ చేయాలో మీకు తెలియాలి ఇక్కడ. సో అర్లియర్ ఇట్ ఈస్ లైక్ అండ్ గేట్స్ ఉన్న చోటంతా అండ్ ఇన్వర్ట్ తో రీప్లేస్ చేసాము నాన్ గేట్స్ కావాలంటే, అండ్ ఆర్ గేట్స్ ఉన్న చోటంతా కూడా వి రీప్లేస్ విత్ ద ఇన్వర్ట్ ఆర్. సో హియర్ ఇన్ కేస్ ఆఫ్ నార్ ఇంప్లిమెంటేషన్, సో యూ హావ్ టు రీప్లేస్ ఆల్ ద అండ్ గేట్స్ విత్ invert AND gates, okay, and all the OR gates with OR invert graphic symbols, okay, and afterwards the compensation is your choice, okay. So whenever I want to use the inverter, so use a single input NOR gate, because single input NOR gate will also function as the inverter here, okay. So if I want to use the inverter, or if I want to change the inputs, you can change. If I want to compensate, so we can change the inputs also. Clear?
Okay, sir.
Yeah.
Yes, sir.
Yeah, so that is a two possibility. So simple గా కావాలంటే ఇది చేంజ్ చేసుకోవచ్చు అంతే మీరు. సో ఇది చేంజ్ చేసుకుంటే సరిపోతుంది. సింపుల్ థింగ్ ఇస్ లైక్ we can like just like the simple one, earlier one, we can change it. Clear?
Yes, sir.
Multi-level NAND and NOR implementations. Okay, so NAND and NOR implementations కూడా ఇస్తారు, but these are very simple, seriously. But they may be appearing as lengthier one, but these are very very simple ones, right? So this is all about your NAND and NOR implementation. So next class we'll see the Tabler method or Quine-McCluskey method. So if possible, I'll take the class in the afternoon session. So we'll discuss the Tabler method, the initial steps of the Tabler method. Okay, then by tomorrow I think we'll be done with this first problem. So first problem I poly, and second problems in the Saturday. So most probably by Saturday I want to finish this first unit. Okay, so any topics which are pending, I'll let you know. Like ఏమన్నా ఉంటే చెక్ చేస్తాను, సో చెక్ చేసుకొని I'll let you know, right? So topic
Okay, sir.
yeah. So I'll 12:01 కంటే చెప్తాను, 1 hour ముందర ఇన్ఫార్మ్ చేస్తాను if there is a class in the afternoon session. If I'm not busy, if I stay home, I'll definitely take class. If I stay in college, I don't know. Right? Depends upon my schedule.
Okay, sir.
Right? Yeah. Thank you, and have a nice day, and see you in the afternoon if possible. So drop your attendance.
Thank
Yeah.